Assalamualaikum warahmatullahi wabarakatuh. For Lab 1, DSP Introduction to Signal Analysis. My name is Azimah binti Zainal Abidin and my partner no ALIZA binti Mazam. Okay, for part 1, for objective, we need to learn to use simulation tool and understand basic digital signal time characteristic and operation. For part 1, this is coding for common signal, a sinusoidal signal, and we use 3 frequency 3 Hz, and we run the coding. So this is a graph for sinusoidal signal, cosine signal, 3 Hz sampled, and this is amplitude and time. Okay, next exercise. What is the sampling period used in generating the signal? So we use formula T equal to 1 over Fs, and we get 0.05 second. Okay, next for B, we need to change the frequency S1 to 70 Hz and plot the frequency 4, 5, 7, 60, 50 and 30 Hz. So from observation, we can see aliasing happen at 70, 60, 50 and 30. It's aliasing happen because we changing the frequency of S1 from 3 Hz to 70 Hz has no effect on the signal. As a result, the two signals will be regarded to have the same frequency even if their frequency have different. This is due to the absence of Nyquist criterion Fs more than 2F in this case. The Nyquist requirements are not violated when the frequency is changed to 4, 5 or 7 Hz, but they are violated when the frequency is changed to 60, 50 or 13 Hz. Fs is not 2 times of signal original frequency. So for C, which of a signal generated will not compliant? So the answer, Nyquist sampling theorem is violated by the signal 60, 50 and 13 because the Fs bigger than 2F criterion does not apply to them. Okay, what is the maximum frequency of F1? The maximum frequency is limited to 10 Hz. If this value is appears, aliasing occur. Okay, next I will pass to ALIZA.
Okay, for part 2, for part 2 we have to come up with the graph, this graph 2 times 2 matrices. Okay, for part 2, first we have to input the rectangular signal. So this is the coding for rectangular signal from line 3 to line 10, and then subplot 2 to 1. Okay, for line 12 to line 19 is the coding for the unit impulse signal, and then we have to subplot 2 to 2. And then from line 21 to line 31 is the coding for sync signal, and then we have to subplot 2 to 3. And then for the coding from line 33 to line 40 is the coding for exponential signal. Okay, and we subplot 2 to 4. Okay, so we run the coding. Okay, as we get here, this is the graph. This is the graph for this coding, and then we get the same graph from the MATLAB and the lab sheet. Okay, first one is the rectangular signal, and second one is the unit impulse signal SB, and then the third one is the sync signal, and then the fourth one is the exponential signal. Okay, so we go to the part 2, basic signal operation in time domain, where we have to generate sinusoidal signal x2a and x2b, and then we have to input the frequency of F2a is 3 Hz and F2b is 5 Hz, and then we have to input the sampling frequency for 3 Hz and then the sampling frequency for 5 Hz. Okay, so as we can see here, we have to input the frequency and the sampling frequency for 3 Hz, and then this is the frequency for 500 Hz, and then this is the sampling frequency for 500 Hz. And then we have to subplot subplot the sinusoidal signal for 2A and 2B, and then this is the part for we have to do the wave file. We have to we have to save the file into sine 1 wave, and then this coding for the we have to save the file to sine 2 wave. Okay, so we run the coding. Okay, so as we can see here, this is the result that we get for part 2. Okay, so this is the graph for 3 Hz, and then this is the graph for 5 Hz, and then the X label is in time, and then the Y label is an amplitude. Okay, for exercise, what is the two parameter of the signal that we are needed to adjust to be equivalent before we can mix them? First, with the length of the signal vector L2A and L2B, and then the second one is the sampling rate of signal FS2A and FS2B. Okay, so we move on to next question. Okay, so the next question that we have to use the function audio read function to generate the to hear the what is the sound like. Okay, first, okay, this is the coding, and then the first one we have to use the audio read function. Audio read function sine 1 wave from the previous question, and then sine 2 wave from the previous question. Make sure the sine 1 and sine 2 wave is the same file in the coding file. Okay, so we run the coding. So we have to input yes here at the command window, enter. Okay, as we can hear the beep sound. Okay, that's all from this question. Okay, so we go to the question C. Listen to the playback of the output compare of the constituent signal. Has the operation achieved its purpose of signal missing? So the answer is yes. It was successfully achieved. We were able to hear the sound after the signal miss occurred. Okay, so we go move on to the next question. So for the next question, we have to do the convolution mixing the two sinusoidal signal. First, we have to generate the sinusoidal signal for rectangular signal. In the second one, we have to generate the sinusoidal for sinc signal. Okay, and then the third part, we have to do the convolution between the rectangular signal and the sinc signal. So this is the coding from line 3 to line 10 is the coding for rectangular signal, and then from the line 12 to line 22 is the coding for the sinc signal, and then from line 24 to line 31 is the coding for the convolution, which is we mix the rectangular signal and sinc signal. Okay, so we have to use the command for convolution function, and then we have to use the length, and then we subplot 313, and then we stamp the n underscore y comma y, and then we label it as a convolution. So we run the coding. So as you can see here, this is the result from this coding. The first one is the rectangular signal Sn, and then the second one is the sinc signal Hn, and then this is the last one, the last graph is for the convolution between sinc signal and rectangular signal. In amplitude, the y label is amplitude and the x label is in n. So we move to the question: what is the length of the convolution output? How is the convolution output length Ly related to input signal Lx and the system impulse response length Lh? So the answer is 40. Convolution is used to describe the relationship between two signals, which are the input signal and impulse signal and the output. And then for next question, what is the convolution output for impulse signal, unit impulse signal, and sinc signal? What can we conclude about unit impulse in convolution? So the answer is the output convolution for both unit impulse signal and sinc signal are the same length. Signal that convolve with impulse will result in the same signal. So unit impulse is the identity signal for convolution. So the next part I will pass to Azimah Zainal Abidin.
Okay, thank you to ALIZA. So for question 3C, same with question 3A, we need to find unit impulse signal. So this is coding for unit impulse signal, signal XB. So this is coding for sync signal. And then this is coding for convolution between Xn and Hn. We use convolution function. So we run the coding. Okay, as you can see here, this is the output we get. This is a unit impulse signal Xn, and this is a sync signal Hn, and this is convolution. So we combine the output between unit impulse signal and sync signal, so we get the convolution output. Okay, next, last part, we need to write the coding with and use a difference frequency 11250, 22500, and 44100 Hz. So this is a sample for 11250. Run the coding to get the output. Okay, as you can hear the sound car, racing car and drum. So this is a graph we get. And then next we change the frequency 22500, and then we run. So as you can hear the sound car racing and drum. So we change again frequency 44100 Hz. So we run the coding again. So you can hear the sound. So from the experiment 3D, we can conclude difference in sound frequency are the main important things to the sound. When using frequency 11250 Hz, we can observe that the sound is not clear. The frequency at 44100 Hz, we were able to get clear voice of racing car and drum sounds. So we can conclude that the higher the frequency is better the sound, and the speed of the sound more faster than before. Okay, that's all from us. Thank you.